Hello everyone, this is my Physics 102 lab project. My name is Anıl Doğan, and my project is about magnetic field strength and magnetic flux. This is the theory of my experiments, and these are the equations that is used to carry out this experiment. The equation on the left part of the page is magnetic field strength of a magnetic dipole. It is a magnet in this case, in the case of this experiment. For this equation, V is the magnetic field strength in Tesla's, mu0 is the permeability of free space, 4 pi times 10 to the minus 7, and R is the distance from the magnets, which is in meters, and the capital M is the magnetic moment of magnets. And on the right part of the page is a magnetic flux passing through a region. It's a simplified equation for a complex surfaces. You have to take the surface integral times surface integral of b dot dA. And in this equation, the shape on the left represents magnetic flux in Webers, and B is the capital B is the magnetic field strength in Teslas, and A is the perpendicular area to the magnetic field in meters squares. This is my setup for this experiment. You can see a Gauss meter at the left part page. This is a Gauss meter which measures the magnetic field strength, and this is the first area I used. Under the area there is a magnet. These are the different areas I used to calculate the magnetic flux. This is how I carried out the experiment. I first calculated the areas by using ruler, and I placed the magnets under the area and put the Gauss meter near, and put the pointer of the Gauss meter over the surface, and I calculated the distance from the surface, and I recorded the values and repeated it with different areas and distances. These are my data. You can see in that data's magnetic flux is higher with bigger area that the magnetic field lines can pass, and magnetic flux is lower with the higher distance from the magnetic dipole magnet in the case of this experiment. And the error percentage is low for the 1, 2, and the fourth one, and the error percentage is 50% in the 55% in the third one, which is high. The errors caused by the sensitivity of the equipment that I used, and inaccurate, uh, not inaccurate, but not fully accurate measurements in the distances. This is the graph of the magnetic flux with respect to the distance that I drew with the Python by using Python. And that's it. Thank you for listening.